Now, a histogram is another way that we can describe information or describe our data. And a histogram is a graph of frequency information, and the height of each bar in the graph represents the frequency of each value. So here's an example of a histogram. So what we see is that here are our values here. Our measure is from 0 to 10, and here is the frequency. So in this case, the number of individuals who indicated a 3 on job happiness, the frequency was 3. Number of people who indicated a 4 was only 1. So the steps in making a histogram: the first step is same as what we did to do a table. Basically what you do is you make a frequency table, a group frequency table. Second step is you put your values of your measurement at the bottom. For example, if this was our job happiness scale. And then the frequencies go along here on this axis. And your frequencies, of course, will depend on how tall you make this. Is what's the largest frequency that you have in your data. And then step 4 is you make a bar for each value. Now, from a histogram, we can also see what's called frequency distributions. And frequency distributions show the sort of the pattern of frequencies sort of combined. How, for example, how the frequencies are spread out, how close they are, and so forth. And the way that you create a frequency distribution from a histogram is you just take and make a line from the top of each of the bars. And when you finish and you take away the bars, then you get a line graph, such as this. And the line graph can actually tell us quite a bit of information. We're going to be using these distribution graphs all through this course. So you're going to see these quite often. And for example, the information that this graph gives us is we can see here that the most frequent score given is a 7. And we can also see if this is job happiness, we can see that most people are give higher scores on job happiness than lower scores, which information that tells us is that more people are happy with their jobs than unhappy. Now, some characteristics of frequency distributions. One is its modality. This is an example of a unimodal distribution. What unimodal means is that there's only one high point in the distribution. So here it looks about 3, that the highest frequency, or the frequency or the the value is for 3. A bimodal distribution is where you have 2 fairly equal points. So for example, we have, looks like our frequencies for 3 and 8 are both high. And then multimodal is when you have 2 or more high points. This is an example of a rectangular distribution. You'll see something like this if pretty much all of the scores are the same. So we can see here that between 1 and 9, 3 people indicated their frequencies of 3 for all of these scores. You actually don't see that very often. Another characteristic of a frequency distribution is whether or not it is symmetrical or skewed. This is an example of a symmetrical distribution, and you can see that it is symmetrical. Like if you divided this in half, it would be pretty well, each half would be equal. Skewed distributions are distributions where scores pile up on one side or the other. Now this is something important because I can guarantee you this is definitely going to be in the exam. That characteristics, how do you recognize the type of skewed distribution is based on the tail, which is this low end here. So this is what's considered a negatively skewed distribution. The tail is here to the left, but the majority of the scores are up here to the right. But you always look at the tail. So that's something to remember. The tail when you're looking at how you name a skewed distribution. Here's an example of a positively skewed distribution. Here the tail is at this end, the tail is to the right, and we have the majority of the scores here at the bottom of the scale. Now sometimes we'll have what's called floor and ceiling effects. A floor effect occurs when all your scores pile towards the end of the distribution, but they don't go below because it's not possible to have a lower score. So for our scale, we're talking about number of children between 0 and 10. First, it's not possible to go below 0. Second, when you look at this, people tend to have smaller number of children than larger number, so we can see how that is skewed here to it's skewed to the right. So this is a positively skewed distribution with a floor effect. Here is an example of a ceiling effect. It's where scores pile towards the upper end, and there's not possible, you've gone to your limit and you can't go below that. And an example would be a very easy statistic test, and most people are scoring at the very end, and you have a lot who are not, you don't have a lot who are scoring poorly on the exam. Floor and ceiling effects also sometimes indicate a poor measure. Basically, it's a measure that may not be sensitive enough to get the high scores or the low scores. And one last thing to talk about in terms of distribution is the shape of the distribution. We can have what's called a normal curve or bell shape, and we will see quite a bit of this in this class. You can see it's unimodal, symmetrical. Okay, and then we have a light-tailed distribution, and you can see here the dotted line represents the light-tailed, and that we have more scores in the middle and less scores at the end. And actually, it's not it's the solid one. The dotted represents the normal. So to give you an example of comparing the light-tailed to the normal. And here is an example of a heavy-tailed distribution, and where you have more scores in the tails than you do with a normal or a light distribution. Okay, that is the end of the lecture for Chapter 1. Please, if you have any questions, you can email me, and or use the question box on the website.